Pando, tree. Pando, Latin for I spread, is a clonal colony of an individual male quaking aspen, Populus tremuloides, determined to be a single living organism by identical genetic markers and assumed to have one massive underground root system. The plant is located in the Fremont River Ranger District of the Fish Lake National Forest at the western edge of the Colorado Plateau in south-central Utah, United States, around 1 mile, 1.6 kilometers southwest of Fish Lake. Pando occupies 108 acres, 43.6 hectares, and is estimated to weigh collectively 6,000 tons, 6 million kilograms, making it the heaviest known organism. The root system of Pando is estimated to be up to several thousand years old, placing Pando among the oldest known living organisms. Pando's long-term survival is uncertain due to a combination of factors including drought, human development, grazing, and fire suppression. The Western Aspen Alliance is studying the tree in an effort to save it in collaboration with the United States Forest Service. In areas of Pando lacking adequate protective fencing, grazing animals have prevented Pando from developing enough young stems to fully replace existing older stems as they die. This decline in recruitment of young stems began in the 1980s and has been attributed primarily to mule deer, though Pando also undergoes restricted grazing by domestic cattle and is potentially browsed by elk. History. Pando was identified in 1976 by Jerry Kemperman and Burton Barnes. Michael Grant, Jeffrey Minton, and Jan Linnert of the University of Colorado at Boulder re-examined the clone in 1992, naming it Pando and claiming it to be the world's largest organism by weight. Both teams of researchers described Pando as a single asexual reproduction organism based on its morphological characteristics. Genetic sampling and analysis in 2008 by Jennifer DeWoody, Carol Rowe, Valerie Hipkins, and Karen Mock of Utah State University and the University of Southampton confirmed the earlier analyses and increased the clone's estimated size from 43.3 to 43.6 hectares. Paul Rogers and Darren McAvoy, also with Utah State University, completed the first comprehensive assessment of Pando's status in 2018 and stressed the importance of reducing herbivory by mule deer to conserving Pando for the future. In 2019, Rogers and Jan Sebesta surveyed other vegetation within Pando besides aspen, finding additional support for their 2018 conclusion that interactions between browsing and past and ongoing management have had adverse effects on Pando's long-term resilience to change. While Pando is the largest known aspen clone, and its age has received considerable attention, other large and old clones exist. According to the Organization for Economic Cooperation and Development, OECD, report in 2000, clonal groups of P. tremuloides in eastern North America are very common, but generally less than 0.1 hectares in size, while in areas of Utah, groups as large as 80 hectares have been observed, Kemperman and Barnes 1976. In the semi-arid western United States, some argue that widespread seedling establishment has not occurred since the last glaciation, some 10,000 years ago. Einspar and Winton, 1976, McDonough, 1985. Indeed, some biologists feel that Western clones could be as old as 1 million years. Barnes, 1966, 1975. In 2006, the United States Postal Service published a stamp in commemoration of the aspen, calling it one of the 40 Wonders of America. Size and age. The clonal colony encompasses 43.6 hectares, 108 acres, weighs nearly 6,000 metric tons, 6,600 short tons, and has over 40,000 stems, or trunks, which die individually and are replaced by new stems growing from its roots. The root system is estimated to be several thousand years old, with habitat modeling suggesting a maximum age of 14,000 years. Individual aspen stems typically do not live beyond 100 to 130 years, and mature areas within Pando are approaching this limit. Minton and Grant summarize the development of stems in aspen clones. Quaking aspen regularly reproduces via a process called suckering. An individual stem can send out lateral roots that, under the right conditions, send up other erect stems. From all above-ground appearances, the new stems look just like individual trees. The process is repeated until a whole stand of what appear to be individual trees forms. This collection of multiple stems, called ramets, all form one single genetic individual, usually termed a clone. Range of age estimates. Due to the progressive replacement of stems and roots, the overall age of an aspen clone cannot be determined from tree rings. In Pando's case, ages up to 1 million years have therefore been suggested. An age of 80,000 years is often given for Pando, but this claim derives from a National Park Service web page that does not provide a source for its number and is inconsistent with the Forest Service's post-Ice Age estimate. Glaciers repeatedly formed on the Fish Lake Plateau over the past 100,000 years, and the Fish Lake Valley occupied by Pando was partially filled by ice as recently as the last glacial maximum. Ages greater than approximately 16,000 years therefore require Pando to have survived. Ages greater than approximately 16,000 years therefore require Pando to have survived at least the Pinedale glaciation, something that appears unlikely under current genetic estimates of Pando's age and modeling of variation in Pando's local climate. Estimates of Pando's age have also been influenced by changes in the understanding of establishment of aspen clones in western North America. Earlier sources argued germination and successful establishment of aspen on new sites was rare in the last 10,000 years, and therefore, Pando's root system was likely over 10,000 years old. More recent observations, however, have shown seedling establishment of new aspen clones is a regular occurrence and can be abundant on sites exposed by wildfire. These findings are summarized in the U.S. Forest Service's Fire Effects Information System, documented post-fire quaking aspen seedling establishment following 1986 and 1988 fires in Grand Teton and Yellowstone National Parks, respectively. He found seedlings were concentrated in kettles and other topographic depressions, seeps, springs, lake margins, and burnt-out riparian zones. A few seedlings were widely scattered throughout the burns. In Grand Teton National Park, establishment was greatest, 950 to 2,700 seedlings per hectare. In 1989, a wet year, but hundreds to thousands of seedlings established each year, despite drought conditions in 1986 to 1988 and 1990 to 1991. Seedlings surviving past one season occurred almost exclusively on severely burned surfaces.